Bismillahirrahmanirrahim. In this video, I will perform a randomized complete block design technique in order to analyze the effect of oil and trucks on the fuel economy in the diesel truck engines. We have three different lubricating oil as our treatments: oil 1, 2, and 3. Five different type of engines: 1, 2, 3, 4, and 5. Our response has been measured as fuel economy of the diesel engine using Brake's specific fuel consumption technique. These are all of our 15 response variable values. We have to enter the data in the Minitab software. First of all, I always suggest my viewers to enter the data with respect to the column. So first column will be for the oil, the second column will be for the truck, and the third column will contain the responses. So you will have to enter the data in this way. First of all, write the name of the three variables, two variable and one response. So then we have for each oil type, we know that we have the data for the 5 different trucks. So first of all, write 1 for the 5 times, then write 2 for the 5 times. Similarly, then write 3 for the 5 times. So the data entry for the first variable will be completed in this way. Then we know that each of them has a 5 different type of trucks. So write 1, 2, 3, 4, 5 for the first time. Then just to copy and paste, you will get the data. Then we have to enter the data for the fuel economy. So data entry has been completed. Now we have to analyze. Click on Stat, ANOVA, General Linear Model, Fit General Linear Model. Here select the response variable as fuel economy. My sectors are oil and truck. Then go to graph. In graph, select 4 in 1. Then click OK, then click on results. In the result, please select expanded table because it will give us the percentage contribution of each factor on the response variable. Then click OK and wait for the results. View on in the result, click here output. This is the factor information. Oil and truck both are fixed. Oil has 3 levels, trucks has 5 levels. Come down and let's have a look at the residual plot. The plot number 1 and 3 is showing that there is skewness in the data. So in this case, when we have skewness, we will have to do the transformation. To do transformation, click on calculator, then calculator. Here we will have to do transformation using different techniques. For example, first of all, I want to do the transformation using some arithmetic function. So in the arithmetic function, we have square root. Click on the square root. After that, here we got number. In place of the number, click on double click on fuel economy. So here become the square root of the economy. We want to save it in the column with the name square root. Then click OK. We will get our values here in the data sheet. Now this is our response variable. Using this data, we will again perform the general linear model. Click on Stat, ANOVA, General Linear Model, Fit General Linear Model. In place of this fuel economy, we'll select the square root data. Nothing else to do. Again, click OK. Now we will check again what our residual analysis will show now. Then click down, output only. Come down in order to view the results. So this time the results is quite better than as compared to the earlier. Let's do 1 or 2 more transformation to check what will be the response if we select other transformation. So click here on the in place of the arithmetic. Now I want to test one of the logarithmic transformation. Again, here come the logarithmic. So here we will select log. We need our data for the logarithmic transformation in the column with the name log. Then click here log base 10. Again on the place of numbers, click on double click on fuel economy. Then click OK. So we got our result for the log in this column. Then again perform Stat, ANOVA, GLM, Fit General Linear Model. Click OK. Again, you will have to check your residual analysis result. In the residual analysis result, we see that almost the data transformation results are similar. As now the data transformation for the log has been completed. Again, perform the GLM. So Stat, ANOVA, GLM, Fit General Linear Model. Here select the log data. Then click OK. Wait for the results. and we got our result. Come down and let's have a look. So no, I think the square root data is quite good. You can do a lot of other transformations like exponential distribution, exponential transformation, log of natural log of base 10 we have performed. So whatever the data will give you the best result for the residual analysis, use that one. So here I will use the square root data. Then I come up and here we can see that the model summary suggests that 91.37% variation in the response variable. Still we say the response variable is over. Square root data for the fuel economy has been explained by the oil and the trucks. Now the next thing is analysis of variance. Now we will discuss ANOVA table or analysis of variance table. The decision for the ANOVA table will be made on the basis of p-value. If the p-value is less than 0.05, that is our significance level, or cutoff value, we suppose or we say that that factor is found to be significant, or there is a significant difference among 3 oil types on the fuel consumption. Similarly, we saw that there is a very significant effect among the 5 different trucks engine on the fuel economy because the p-value is too less. Further, the most important thing that's in this problem, 88.44% variation in the fuel economy is just only due to the 5 different type of engines. So that's the most interesting thing. Now, as per the instruction given in the question, that we have to perform a Fisher LST. Why? Because our results are found to be significant. So we will perform a Fisher LST for oil because this is our treatment variable, not for the truck because this is the blocking factor. In order to perform the post-hoc test, click on Stat, then ANOVA, one-way ANOVA. In one-way ANOVA, again select your response variable, square root of the data, and then I have the factor oil for which I want to perform the analysis. Click on comparison. In the comparison Fisher, here click on the test. This is most important thing. Please must take care of this. Then click OK and then OK. We will get our post hoc test result. Then come down. So we can see that the ANOVA result is found to be significant. Why? This is again the most important concept. Because we haven't separated our blocking effect from this error term that make the ANOVA insignificant. So in this case, there will be no need to go in the details of the Fisher LST because there will be no significant difference among all pair oil type 1 and 2, 1 and 3, 2 and 3. So now after this, we will go towards stat for the response optimizer. So stat, ANOVA, general linear model, response optimizer. In the response optimizer, we said that we want to optimize our result for the square root data and we want to minimize our fuel as much as possible, nothing else to do. Here just I'm going to tell you that setup it's okay. Our objective is minimum. In the options it's okay, the most important thing is constraint to the region that are available, bounds we have. Then click OK, nothing else to do. If you go to the graph, optimization plot has been already selected by default. Then click OK, and then we got our result. So here we can see, so the result of the prediction tells us that oil type 1 and truck type 4 is found to be best one with the composite desirability value of 0.864. That's quite high. Then again you can see graphically the optimal are oil type 1 and 4. If you want to see it graphically, then go to stat and then here ANOVA, GLM, factorial plot. You will see all of the result graphically. Here I want to do it on square root data. Click OK and then wait for the result. So here we can see that the least fuel has been consumed at for oil type 1. So that's the best one oil we have. Then if you want to check the same thing in the regression analysis equation, click on the result for the regression model. Here we will get also the result for the regression analysis equation. So we can see it here that oil type 1 and oil type 3, they are decreasing the response variable fuel consumption. Or you can see the oil type 2 is increasing the fuel. For the trucks, we have 5 different trucks. Since this is a blocking factor, there is no need to discuss. However, and further, you can also drop it from the analysis. And if you want to see, so the truck type 3, truck type 4, these two are the best one because they are decreasing the fuel. If you have any question, please contact me via WhatsApp or my Gmail. Thanks a lot for watching the video. Have a good day. Bye.